Okay, these are acids and bases notes. Okay, there are two unique kinds of compounds, and they're acids and bases. Acids and bases differ in their properties and how they react. They also complement each other. So let's talk about the properties of acids first. First, acids taste sour. You ever been into a lemon? That's citric acid you're tasting. Okay, that's why it's sour. Acids react with certain metals and produce hydrogen gas. Acids are corrosive and can cause severe burns and tissue damage. Acids react with carbonates to produce carbon dioxide gas. Acids turn blue litmus paper red. There's a little, you know how roses are red, violets are blue? Well, the way to remember what acids and bases do to litmus paper, it's acids are red and bases are blue. Yeah, so acids are red and bases are blue. So it also, acids turn blue litmus paper red, but it also turns the, we're going to do a little lab where we're going to see if something is an acid or a base, and we're using this plain colored litmus paper. So it's got both the red and the blue indicator on it. So if it turns red, it's an acid. If it turns blue, it's a base. So just remember, acids turn litmus paper red. Okay, there's a guy, he's a Swedish chemist. His name is Svante Arrhenius, way back in, I think it was the 1700s. And he studied acids and bases, and he came up with a definition of acids that's a little different than, well, that's actually the general definition that we usually, come to expect with acids. So he said that an acid is any substance that produces hydrogen ions in solution. So if it produces H plus ions, which by the way are called protons, because that's what a hydrogen ion is. You take away that take away the electron. So that's what an ion is. You're taking away an electron. There's only a proton in there. There's no neutrons, so it's a floating proton. So you'll hear me call them protons. I rarely call them hydrogen ions. I always call them protons. Okay? In solution. Now, what happens here is water tends to take up this extra hydrogen ion, and it forms the hydronium ion. Okay? So you'll see the hydronium ion a lot when we're talking about acids and bases here. So like HCl is hydrochloric acid. You stick it in water and it goes H plus Cl minus ions. So here's your H plus ions. So that's why it's an Arrhenius. It's an Arrhenius acid. Okay, bases have different properties. Bases taste bitter. If you've ever bitten into an almond, they taste bitter. Well, and if you've ever had soap in your mouth, that tastes bitter. Both almonds and soap are bases. Almond has a base compound in it, and soap is a base. It's lye. You really don't want to be eating soap. So when you had your mouth washed out with soap, hopefully it tasted awful. Bases feel slippery, which is why soap feels slippery. Bases react with oils and grease, which is why you use soap to clean yourself, because it reacts with the oils and grease on your skin and in your clothes. Bases react with acids to form a salt. Bases are corrosive. Drain cleaner is a strong base. You don't want to be getting that on your skin. If you do, you want to rinse it off right away. Bases turn red litmus paper blue, or any kind of litmus paper blue. Okay, now Arrhenius said that bases produce, oops, guess I would have if I had my pen, produce OH ions in solution. Okay, so things like NaOH. You put that into water and you get your sodium ion plus your OH minus ion. So any time you have an OH in there, a hydroxide ion, okay, then you have a base. Okay, now there are properties of both. Like both are used to make fertilizers. Both conduct electricity when in solution, which means they're an electrolyte. Both are crystalline solids when undissolved. Both react with indicators to produce a color change. Okay? Now water is both an acid and a base, which is called amphoteric. So that's the definition of amphoteric. That means it acts as an acid or a base, or both. Well, acts as an acid and a base, I should say, because it produces both H plus and OH minus ions. Okay, next came along Johann Brønsted and Thomas Lowry, and they were studying acids, and they were like, well, Arrhenius had a good idea, but we have a problem with that. There are lots of compounds that don't have OH minus ions, but still act like a base. They're still bases. They have all the properties of a base, but they don't have OH. So, I mean, think about it. Think of ammonia. Ammonia is a base. You put it in litmus paper and ammonia, it turns bright blue, well, dark blue, okay? It is a base. Ammonia is NH3. There's no hydroxide ions, okay? So they said, well, we're going to change the definition a little bit because we've studied them a little bit more than Arrhenius did, okay? So let me put on here, for example, NH3. Ammonia, because there's no OH in there. Okay, so a Brønsted-Lowry acid is a substance that donates a proton, which, as I said, is a hydrogen ion, to another substance. Okay, so it gives it away. A Brønsted-Lowry base is a substance that accepts that proton from another substance. When the two react, they form a conjugate acid-base pair. Okay, so let's look at it. If we have hydrochloric acid and ammonia, you end up with the ammonium ion and a chlorine ion. So what's happening here is hydrogen is giving its proton to NH3. So this is your acid, and this is your base. Now it's forming a conjugate acid-base pair. Now this reaction, by the way, is reversible. So on the way back, when you're going from left or from right to left, then NH4, you know what, let me use a different color. This might be a little helpful. Because on the way back, NH4 then gives it right back to hydrochloric acid. At this point in time, this becomes the acid, and this becomes the base. So at first, hydrochloric acid is the acid, and then Cl is the conjugate base, because on the reverse reaction, it really is a base. So NH3 is the base, but on the reverse trip, it's the acid, so it's called a conjugate acid. So I'm going to put C acid and C base. So that means on the return trip, it's the opposite. So hydrochloric acid is the acid part, but then Cl minus is the base part. And you can tell, because if you go from hydrochloric acid to Cl, HCl to Cl, it's lost the hydrogen. So HCl to Cl minus is minus a hydrogen ion. It lost it. Okay, it gave it away. And NH3, in becoming NH4, gained it. Okay? So that's why that's the base, because it accepted it. Now, as I said, on the return trip, it's the other way around. So every Brønsted-Lowry acid produces a conjugate base, and every Brønsted-Lowry base produces a conjugate acid. Okay, so let's look at our conjugate acid-base pairs. You're also going to have to figure out charges, because if something accepts a hydrogen ion, that means its charge is increasing by A+. And it can get really interesting when you start out with a minus and then you have to add a plus. So we're going to have to keep track of charges here. Okay? Now, we are going from H2SO4. If it's an acid, it's going to donate, which means it's going to lose. So we're going to put a minus H+. So when you subtract a positive, you're going to end up with not H2. You're going to end up with one shy, so one less. And when you end up with one less hydrogen, you end up with a negative sign. Okay, because you're taking away one of those pluses. And if you remember, with cations and anions, usually we take away or add negative signs. Well, this time we're taking away or adding plus signs. So let's say there was 10 plus signs with H2SO4, and you take one of those plus signs away, you now have 9 plus signs, but you still have the 10 negatives that went with. Because remember, every compound and every substance is neutral. So if you have 10 pluses, you had to have 10 minuses. So just remember, when you take away a hydrogen ion, it becomes negative. You're adding a negative sign. So same with HCl. You're subtracting, so it's minus H plus, giving us Cl minus H plus. So you're missing one, H2PO4 minus H plus, OH minus. Now, what if we had something else? What if we had something like, oh, I don't know, let's do HSO4. Okay, and I'm saying that's the acid. So now to get the base out of that, the conjugate base, you're subtracting an H plus, you're going to end up with SO4. Now you already have one minus sign, so now you're going to get another minus sign. So whenever you go to a conjugate base, it's always one less negative. Okay, so if there's no charge, it goes to negative. Now, what if it's NH4? Okay, now you're going to subtract an H plus and you get NH3. Now notice there's no charge because NH4 had a plus sign, so we're going to subtract a negative from it. Okay, so we're going to pull out, it's going to go down 1. So think of a number line. If it's a positive number, it's a positive 1, it's got to go to 0. If it's 0, it goes to negative 1, negative 2, negative 3. So that's probably the best way to think of this. Think of this as a number line. If there's no charge, you're starting at 0. And when you take away an H, you're going to the left of the number line. You're going, for every H, you're going to the left one. So it's a negative 1, negative 2, negative 3. If you start with a positive, you're still going to the left when you take away an H. So it goes from positive to 0. Hopefully that helps. Okay, let's try bases with the conjugate acid. And it's the opposite with a base. A base is going to increase in charge. So on the number line, it's going to the right. Okay, so if we go, because right now what we're doing is we are going to be adding an H plus. So here in NH3 starts at 0, and then we're going to add an H plus. So we're going to end up with NH4 plus 1. So we go from 0 to plus 1. So on our number line, we're going to the right one. Cl minus, since it's already a minus, so think of that as a minus 1. We're going to add an H plus, which means we go to the right one. So minus 1 plus 1 is 0. So you're going to have HCl. So every time you add an H, you're going to the right one space. H2O starts out at 0. So add our H in there, but then we got to add our plus sign. SO4, 2 minus. We're going to add our H. So it's going to be HSO4. Now, we're at negative 2. We're going to go to the right one, which is negative 1. Okay, so I'm hoping the number line symbol, or whatever you want to call it, analogy, there you go. The number line analogy helps you. So just think of it as a number line. Every time you add an H, you're going to the right one. Every time you take away an H, you're going to the left one as far as the charge goes on your substance. Okay? Okay, here's a good example. For the following reversible reactions, label the acids and bases and show the direction of proton transfer. So what I want you to do here, pause the video and see if you can't figure out which is the acid, which is the base, which is the conjugate acid, and which is the conjugate base. Remember, acid base is going to be on the left, conjugate acid and conjugate base is on the right because it's the return trip or the reverse reaction. Okay, so pause the video. Now, I'm going to give you the answers, obviously, because that's what this is for. Okay, so for the first one, it doesn't matter which way you do it. You can go left to right, right to left. One of the waters gives up a hydrogen, so I like to label. Oh, and also with your arrow, acid always goes at the end of the arrow where it starts, so where there's no arrowhead, and then the base goes where the arrowhead is. Okay. Now this one does matter. On the right hand side, you have H3O plus and OH minus. OH minus is not going to give up another hydrogen, it's going to accept it. So we are going to write it like this. Okay? So this is your conjugate acid and your conjugate base. And you can write the word out, conjugate acid and conjugate base, or you can put C point acid, C point base. I know what it's talking about. So on your classwork, if you put C acid and C point acid and C point base, I'll know what you're talking about. Okay? So let's go down to the next one. NH3 to water. Well, NH3 ends up, looks like ends up getting one, and water ends up losing one. So you got to follow the hydrogen. So in order for NH3 to go to NH4 plus, it had to add an H plus, okay, which means it's the base, which means the arrowhead goes where the base is, and the end of the arrow goes where the acid is. Okay, so water gave up a hydrogen, gave it to the ammonia, and then produced ammonium and hydroxide. Now, this is going to be the conjugate base. By the way, hydroxide is always the conjugate base. It will never ever give up that other H. So OH minus equals always the conjugate base, or some sort of base. It's always a base. Sometimes you can start out with the base, but it's always a base. So let's erase the conjugate, because it's not always a conjugate, but it's always the base. It could never be an acid because it does not give up. Because that O and that H are actually covalently bonded. So it's not going to happen. Okay, so hopefully you get this. We'll do more of this in class tomorrow. And I hope everybody got the notes. First period, hopefully, if you spread the word, if you realize that there's notes, spread the word to everybody else. I know I said there was a possibility, but I emphasized it more with third and fourth. So I guess I will see you guys tomorrow. Bye.